Hello, hello. We are covering 5.3 polynomials and polynomial functions in this video. Take notes. So we're going to spend most of this time looking over the parts of the polynomial. And then at the very end, we're going to take a look at how to add and subtract polynomials, and that'll be it. Okay, so polynomials. And polynomial functions. Okay, so first of all, we need to make sure that you know what a polynomial is. Okay, so it's a single term or the sum of terms. So a single term or the sum of terms in which all variables have whole number exponents. You may remember in your last math class, fraction exponents exist, and they represent like radicals, square roots, cube roots, and whatnot. Okay, so a polynomial, the exponents are whole numbers. Whole numbers also means no negatives. So we just looked at negative exponents in the previous section. So polynomials, they don't have any negative exponents, no fraction exponents. Okay. And also, no variables appear in the denominator, because then we're dealing with rational functions, not polynomials. Okay, so let's take a look. So these are the ones that are examples of polynomials. So you might have something like this, 5x plus 3. That's a polynomial. You might have something like this, 4n squared minus 6n minus 8. Okay, that's a polynomial. You might have something like this, p cubed plus 3p squared q plus 3pq squared, that's my q, plus q cubed, that's a polynomial. Okay, so all the exponents are positive whole numbers. Okay. Even this, you can have fraction coefficients, you just can't have fraction exponents. Are s squared t to the fourth. Okay, so all of these are examples of polynomials. So here are some examples that are not. Okay, so for example, this 2x, x squared plus 1, because we have variables in the denominator. That's not allowed for polynomials. This one, 6y to the 1/2 minus 8. And this is not, because we can't have fraction exponents. Okay, and this one here, c to the -3 plus 2c plus 2. This one is not, because we can't have negative exponents. Okay, no fraction exponents, no negative exponents. Okay, so we have names for certain polynomials. So we have the monomial. So mono 1. So these are the one-term polynomials. Okay, so for example, maybe you have 2x cubed. That's a monomial. If you have a squared b, that's a monomial. If you have 3x cubed y to the fifth z squared, that's a monomial. One term. You don't have any addition or subtraction. Okay? A binomial, that's two terms. Okay? So you might have something like this. 2x plus 5. Two terms, 2x and 5. Okay? Or you might have negative 17 halves x to the fourth minus 3/5 x. Again, you still have only two terms. The first term is negative 17 halves x to the fourth. That's one term. The other one is negative 3/5 x. Okay? All right. Trinomials. So that's three terms. Three terms. So something like this. 2x squared plus 4x plus 3. We have three terms here. 2x squared is one term, 4x is another term, and 3 is another term. Three terms. That's a trinomial. Or maybe you have something that looks like this. This is also a trinomial, three terms. So here the first term is 3mn cubed. The second term is, you actually have to say negative. So the second term is negative m squared n cubed. And the third term is 7n. Okay? Even this one, negative 12 x to the fifth y squared plus 13 x to the fourth y cubed minus 7 x cubed y cubed. This is also a trinomial. As we see, we have, this is all one term. Negative 12 x to the fifth y squared. That's one term. This is the second term. 13 x to the fourth y cubed. And this is your third term. Negative 7 x cubed y cubed. Okay? All right, degree. The degree of a term. So we'll first look at the degree of a term, and then we'll look at the degree of a polynomial. Okay? So the degree of a term. When you have just one variable, it's pretty straightforward. If you have more than one variable, then there's a little bit more to it. Okay, so if one variable then the exponent on the variable is the degree of the term. Okay, so for example, if you have this 5x to the third, then here the degree of this term would be that exponent, which is 3. Okay, now if you have more than one variable, so if more than one variable, then the sum of the exponents on the variables is the degree. Okay, so for example, if you have this for x cubed y squared, then here the degree would be the sum of the exponents on the variables. So if this guy had a variable, I mean an exponent, you wouldn't count it. So it's the ones that are on the variables. So here, 3 and 2. So the degree here would be 5. Okay. All right. So the degree of the polynomial okay, so it will be the highest degree of all the terms. Okay, so the highest degree of all the terms. Okay, so for example, if I have this polynomial 3x squared minus 5x plus 2, so if I look at each term, the degree of this term is 2, the degree of this term is 1, and the degree of this term is 0, because that's like an x to the 0, which is 1. Okay, but the exponent would be 0. So this is degree 0, degree 1, degree 2. So the highest degree, it would be this one. So the degree of the polynomial would be 2. Okay. If I have this one, suppose that I have 5m12 minus 3m10n4 plus 7m8n6 plus mn9. Okay, so if I take a look at the degree of each term, the degree of this term is 12. The degree of this term is 14. The degree of this term is also 14. And the degree of this one is 10. So the highest was 14. So the degree here would be 14. Okay. All right, polynomial function. Okay, so this is just a function defined by a polynomial in one variable. So a function defined by a polynomial in one variable. So we looked at some examples here where you had polynomials with 2 variables, like this one up here. So that wouldn't be a polynomial function. That's a polynomial, but it's not a polynomial function. So it's a polynomial in one variable. So like this one. Okay. All right. And instead of using y equals, we use our function notation, f of x, or maybe p of x, or h of x. So f of x is equal to x cubed minus 3x squared plus 9x minus 2. This is a polynomial with one variable, the variable being just the x. Okay, and we evaluate these the same as before. So evaluate same as before. So if you are trying to find f of 2, right? Remember, this means to replace all the x's in our function, replace that with 2. So 2 cubed minus 3 times 2 squared plus 9 times 2 minus 2. Okay, and you still work this out the same way. 2 cubed, 8. Order of operations, exponents first, and then multiply. Okay. All right, so what we want to focus on here is adding and subtracting polynomials. Okay, so Let's take a look at that. So what we end up doing is combining like terms. Okay. If you have subtraction, then you just need to make sure that you distribute the subtraction. Okay. So let's have a look. Let's do this polynomial, 3x squared minus 2x plus 4. And let's go ahead and add this with this polynomial, 2x squared plus 4x minus 3. Okay. All right. So here, this is addition. So I'm just going to go ahead and combine like terms, positive 3 and positive 2. So x squared, these are like terms. This x and this x term, those are like. And the 4 and the negative 3, these are like terms. Okay. All right. So 3x squared plus 2x squared is 5x squared. Negative 2x is like terms with positive 4x. So negative 2x plus 4x is positive 2x. Okay. And then here, positive 4 plus negative 3. Positive 4 plus negative 3 is positive 1. And that is your final answer. Okay. All right. Let's take a look at another one. Suppose that I have this polynomial, negative 5x cubed y squared minus 4x squared y cubed. And I'm going to add that with 2x cubed y squared plus x cubed y plus 5x squared y cubed. All right, so we need to first identify the like terms. All right, so the way you identify them is by their variables and the exponents. The variables and exponents need to match, okay? So here we need to look for all the x cubed y squares. No. Here's one, x cubed y squared. No, and no. Okay, so this one, negative 5x cubed y squared, and this one, okay? So negative 5 and positive 2 is negative 3. Okay. Since we have several terms here that may or may not match up, I'm going to go ahead and cross them out as soon as I combine them. That way I know I took care of all of them. Okay, so here I'm looking for x squared y cubes. Here we go, x squared y cubed. So here, negative 4 plus 5. Negative 4 plus 5. That's 1. Positive 1. I don't have to write the 1. And it's x squared y cubes. So we're done with that. And then we have this lonely x cubed y all by itself. So we'll just bring that down like so. Okay. Let's take a look at subtraction. So again, here with subtraction, you just have to make sure that you distribute the subtractions, in which case the signs will change. Okay, so suppose that I have this, 8x cubed plus 2x squared, and I'm subtracting 2x cubed minus 3x squared. Okay, so here I'm going to actually do an extra step. So before I start combining, I am actually going to bring this down, but now I'm going to distribute this subtraction. So I'm going to put down negative 2x cubed and this will become positive 3x squared. Okay, so when you distribute this negative, this becomes negative 2, and this becomes positive 3. Okay, so when it's subtraction, I will do this extra step before I start combining like terms. All right, so now I'm looking for the x cubes here and here. 8 minus 2, that's 6x cubed. And then 2 plus 3, that's 5x squares. Okay, go ahead and try this one. So you'll hit the pause button, and then you'll come back and see if you got the same answer as I did. Okay, all right. So go ahead, hit the pause button, and come right back. All right, if you got the answer negative 2x squared minus 4x plus 5, you are correct. So negative 2x squared. Here, this is the answer. You're going to get negative 2x squared minus 4x plus 5. So if you got that for your answer, you are correct. If you didn't, then continue watching. So here, I'm going to bring this down. And here, I'm going to distribute the negative. So negative 3x squared, negative x, and minus 3. Okay, I'm going to combine the x squares. So that's 1 minus 3 is negative 2 x squares. I'm going to combine the x's. That's negative 3x and negative 1x. That's negative 4x. And here, positive 8 minus 3 is positive 5. So that's how we get the answer. Okay. All right, so that is it. If you have any questions, make sure that you email me or you message me, but make sure you keep up with the homework. I'll see you next time.